Hi, my name is Yashin. I'm a sophomore at Niles West High School. My project is experimental. My project name is the effects of excessive caffeine consumption, vaping, and alcohol use on C. elegans mortality and movement. Introduction. In the last decade, caffeine consumption has reached an all-time high. A majority of caffeine consumption is through coffee, energy drinks, soda, and tea. There are a large amount of studies that demonstrate the benefits of caffeine consumption. Given the overwhelming amount of research surrounding caffeine consumption, there is a lack of studies that have uncovered the negative effects. A negative effect that is prevalent to those who continuously consume caffeine is addiction. Other minor effects of caffeine consumption are restlessness, dizziness, and headaches. However, caffeine is one of the most commonly used drugs. Other commonly used drugs are alcohol and nicotine, which both have great amounts of research describing the negative health effects. With the information from the given research, it is unsure whether or not there will be similarities or of the after effects of caffeine, nicotine, and alcohol use. Uncovering the negative effects of caffeine on human health is essential due to the rapid increasing use in the US and the rest of the world. Relevancy. In the past 10 years, vaping, alcohol use, and caffeine consumption have all gone up. There have been numerous research projects on the negative effects of alcohol and vaping, but not on the negative effects of caffeine. This is really concerning because caffeine consumption has increased so much even in teens. By doing research on this topic, I'll be able to spread awareness of any negative effects that caffeine has on all of its users worldwide. Hypothesis. Caffeine, nicotine, and alcohol overuse and addiction is a growing problem in the US, which C. elegans can model. Drug use can be shown in C. elegans through movement and mortality. While negative effects of caffeine and nicotine and alcohol are already known, caffeine remains untouched. Because of this, research is needed to uncover the potentially harmful effects of high usage of caffeine. If C. elegans are constantly exposed to caffeine, nicotine, and alcohol over the period of 2 weeks, then the C. elegans groups exposed to caffeine will show the same effects as the C. elegans groups exposed to nicotine and alcohol. Caffeine. There's been a lot of research on the positive effects of caffeine. As a result of consistent caffeine usage, consumers have demonstrated behaviors of increased productivity and their ability to learn. Because caffeine has been found to have these effects, it has been classified as a stimulant. The average dosage of a caffeine that would be used in research would be 5 UL. The small amount is because overconsumption of caffeine isn't lethal but can still lead into health issues. One research project done by Seven, which is my peer, involved the exposure of caffeine to C. elegans. His research he conducted involved the effects of caffeine on C. elegans with high glucose levels. His data showed that there is a high rate of immobility in experimental groups with caffeine dosages over 5 UL. As a depressant, alcohol slows brain function. Some effects of alcohol consumption includes change in mood, slowed brain function, and others. These effects are the reasons why health officials suggest that those under the influence should not be driving. Alcohol cannot be digested, so it travels through your bloodstream very quickly to every part of your body. It first affects the brain, then the kidneys, and finally the lungs and liver. Alcohol is used by so many people to calm down or de-stress, and because it works very well to do so, people become addicted. And in this experiment, I am not allowed to use actual alcohol, so I would be substituting with ethanol, which is the main ingredient in alcohol. Electronic cigarette juice has had a long list of ingredients. In an e-cigarette, the juice is vaporized and the user breathes in the air. Those ingredients make the experience pleasurable. The main ingredients are propylene glycol, vegetable glycerin, and nicotine. The ingredient that makes electronic cigarettes so highly addictive is nicotine. Electronic cigarettes would be very hard to model in an experiment due to the high temperature of the vapor that is in an electronic cigarette. It would result in the death of a C. elegans. This was seen in the past experiment conducted by Motadi Syed. Syed's experiment demonstrated vaporizing propylene glycol, which is one of the main components of electronic cigarette juice, and it resulted in high mortality rates. As a result of this, the electronic cigarette juice in the research would mainly be unheated. The CNS, or the central nervous system, is responsible for sending messages through the body. The process of messages traveling through neurons is very fast. Vesicles, a molecular structure, carry neurotransmitters to the synapse, where they are picked up by receptors. This process is continuously repeated until the messages get received to where it's needed. This process is what stimulants and depressants alter. C. elegans are the organisms that I chose for this experiment and research. The characteristic of C. elegans that separate it from other roundworms is the use of them when it comes to neurological research. C. elegans have 302 neurons and 56 glia. Because of the presence of neurons and glia, they can be a model for neurological research. The neurons and glia are good for neurological research because of their ability to simulate the human nervous system. C. elegans were the perfect model organism for this research. During experimentation, I looked at mortality and movement. The first observation would be movement. There are multiple types of movement: forward, coiling, and reversal. The forward movement is the usual normal way the C. elegans move. Any other type of movement would be a change in behavior indicating change or damage in their neurological systems. The other variable to observe would be death in the C. elegans. Because of the risk of human error, there will be a control group without exposure to any substances to ensure that death is not caused by human error. If death is observed in any of the experimental groups but not in the control, the only two possibilities would be the dosage or the drug itself. In order for the dosage to not kill the C. elegans, the dosage will be pulled from past experimentations. During my research, I used standard procedure to culture the C. elegans and E. coli. I made sure to create multiple groups for each substance in order to ensure that the C. elegans mortality would not be due to any error in dosage. In my experiment, I had 4 different groups. Each group was exposed to different substances. I had different dosages for each group. For example, ethanol had dosages of 20, 30, and 40 UL. After exposure, I collected observations of the C. elegans movement, behavior, and mortality. In order to find the mortality rate, I put clear grid paper under the Petri dish and picked 2 random boxes. Then I counted the number of dead C. elegans and found the mean mortality between the two. Results. After 2 trials of experimentation, I was able to get this data. As you can see in the graph, the propylene glycol experimental group produced the highest average mortality. The 40 UL caffeine group had the highest mortality highest mortality rate, but a relatively low second trial mortality rate. The ethanol groups also produced low mortality rates all throughout the experimentation. Even though the ethanol groups did not produce very high mortality rates, they were mostly higher than the rates of the control group, indicating that some sort of effect presented by the ethanol. The 30 UL caffeine group had a high mortality rate than mostly every other group except for the 40 UL and 40 UL groups for propylene glycol and caffeine. This indicates that caffeine had as much, if not more, of an impact on the C. elegans than the ethanol and propylene glycol. I also observed the movement of the C. elegans. I observed that the caffeine-induced C. elegans exhibited slow and staggered movements, unlike the C. elegans of the control group, which moved at a normal speed. The caffeine-induced C. elegans seemed to have bursts of movement. The control group C. elegans moved headfirst, while the caffeine group C. elegans moved back and forth. Error analysis. While during experimentation, there were some errors that were unavoidable. My data was highly consistent and the standard error was low for most experimental groups. We can see that ethanol had really low mortality rates. This is probably due to the low ethanol concentration that I used. I did this because I didn't want to kill the E. coli that I was using to feed my C. elegans. I could try to administer the ethanol differently through microinjection or using a different model organism that does not rely on bacteria to survive. One more error I could have made was that I did not collect mortality rates very often. I collected the mortality rates after 5 days of just observing movement and behavior. Next time I could frequently check on mortality rates. While doing background research, I wondered what kind of data would support my hypothesis, and it was movement and mortality. The movement that would exhibit the neurological effects of the caffeine, while the mortality rates would show the extent of harm that the C. elegans came across while being exposed to caffeine. This data supported my hypothesis of caffeine consumption having the same effect on the organism's neurological system and their life as nicotine and alcohol. We can see this in the mortality graph. The caffeine graphs are the second and third highest rates in my experiment. Mortality rates in my experiment. The concentration was the lowest out of the 3 solutions at 5% caffeine. The caffeine-induced C. elegans also showed staggered and slowed movements. This shows damage or change in their neurological systems. We know this because this control group C. elegans did not exhibit this movement. This also proves that change is due to the caffeine, not human error. The results that I obtained are possible because, like alcohol and vape juice, caffeine is a drug. Conclusion. Every morning, the total amount of caffeine consumption increases. As more people get their refills of coffee, energy drinks, and tea, their addiction only grows. And with that addiction, changes in their brains and nervous systems. Through this project, alternations in neurological systems that caffeine causes were brought to light. By modeling heavy caffeine use with the C. elegans and comparing them to the C. elegans exposed to alcohol and vape juice substitutes, I was able to find out that caffeine also had the same or even worse effects that these already researched drugs had. By drinking caffeinated drinks in moderation, people can stay away from the negative effects caffeine has on their brains. This shouldn't be the end of the research, though. In the future, I plan to continue this research and dig deeper into what actually happens in the brain when caffeine is overused. Bibliography. Thank you. 11th minute. I learned a lot through the SIRS program. I learned about the scientific process, collecting data, and topics from engineering to biology. I also got a lot of lab experience, which not a lot of people my age get to enjoy and work through. I got to work with a lot of amazing people and learned a lot from them. One skill that I'm happy I improved is working through the scientific process. I learned to set up an experiment and go through the procedure. It was a lot of fun and it taught me a lot.